product lately. I spent half hour trying to get into my email this morning. Okay, we should be good to go with live streaming now. Okay, I'm gonna start share screen. Okay. Thank you for everyone's patience. Can you see my screen all right?
Yep.
Awesome. Welcome everyone. My name is Vivian. I'm the school director of NYCDSA Academy. Before Kyle gets started, I would love to spend 2 to 3 minutes to introduce who we are. So the Academy is a national accredited bootcamp program. There are very few handful of schools are national accredited. So for today's event, you can share your thoughts through either Q&A. You can type your question and send to the host. Not sure why, but the chat is disabled. So we're gonna fully utilize Q&A today. And a little bit about the school. We've been up running since 2013. It's actually almost our 9 years anniversary. And we've been offering bootcamp programs since 2015, January. And we've been getting a lot of Best Bootcamp awards since 2015. One of the rewards actually 7 years running. So we offer bootcamp program, which is focusing on help people to make career transition. We also offer part-time professional enhancement class. We teach both Python and R, and we're probably the only one, as the best of my knowledge, teaching both language in the bootcamp program. A lot of the learning is made through individual project and group project. So we work with corporates, they bring their real world project into the bootcamp, and students get to work with big companies, small companies, startup, all kind of different background and with their real world needs, which is really useful when students go out to hunt for jobs. And if you took our bootcamp program, we offer career service, which means it's lifetime support. A lot of students who graduated back in 2015 probably is getting third job or fourth job from us. And we always want to support you, make sure you're landed at somewhere you will be happy with. And right now we have over 2,000 alumni work across the globe. And we ranked as Best Data Science Bootcamp and Best Online Bootcamps through SwitchUp and the course report. So based on your current status, you can choose full-time or part-time if you're interested in bootcamp. We have upcoming program in September, in November. I believe around half year ago, we released the data analytic bootcamp, which help people have less background people try to break into this industry. So this is a little bit shorter compared to our flagship offering. So the main difference is the machine learning bootcamp has the machine learning component by name. Also, it includes big data and deep learning. And data analytics is focusing on like visualization, data exploration, building dashboard. So typically we see people coming from less background will start with data analytics. Once they land a job as a data analyst, marketing analyst, operation analyst, they can continue their training to finish the machine learning portion. So we can offer it through in-person or live online. We also start to see more and more volume going towards our full-time online and part-time online because more working professionals are picking up the bootcamp now. So the application process is pretty straightforward. You start with submitting an application, just like you apply to grad school. Then you go through an interview process, and we have official tech assessment. So the whole process typically takes around 5 days minimum. And the upcoming cohort are September 26th and November 7th for both data science and data analytics and data science with machine learning program. So we have a lot of amazing alum, including Kyle today. And you can see they landed in different places. We see students coming from California, going back to Silicon Valley. We see people coming from Abu Dhabi, stay in New York City. We see all the students from different places. land happily with the job. So we're very proud to present our alum. And if you have any questions, feel free to write to admissions, and we will get back to you very quickly. And I'm gonna turn the floor to Kyle so we can get started with the exciting topic, designing and implementing machine learning ops. Thank you, Kyle.
Cool. Sounds great. Let me just grab the screen. All right.
Kyle, you're muted somehow. Okay, it's back.
Yeah, that's because I stopped screen sharing.
Oh, it's competing?
Yeah, it's competing with C. Now you can see it? Is it just when I share a Chrome tab?
Yeah.
Okay.
Yeah. Awesome.
Annoying. All right, whatever. Cool. So it's everybody. I'm Kyle. I'm going to be going over the kind of course that I put together for designing and implementing production machine learning systems. Super excited about this. I think it's a very unique course, and it'll be fun to go through. So a little bit about me. I'm currently a senior software engineer on the machine learning platform team at Etsy. Also done like a lot of data science stuff in the past. So I was a data scientist at Pfizer for a while, worked towards machine learning engineer there, like data analyst before that. So I've kind of gone through a lot of different phases in the data science industry. I also do a lot of writing on the side, so feel free to connect with me, check it out, or just chat, even if you're not interested in the course. Also Twitter and all of my Medium articles there. But yeah, I feel like I've kind of held a wide array of roles across the data science and machine learning space that have led me to this current position as a machine learning platform engineer, which I'll talk a little bit about in a little bit. For today, I just want to talk a lot about the motivation behind this course, the curriculum that I put together, the actual deliverables and process, which are going to be super fun. Enrollment requirements real quick. And then if we have time, just maybe an example of like a little snippet of the kind of material that you'll walk away from this course with and the things that you'll be able to build. So one, motivation behind the course. This course is just like an introduction to machine learning systems in production. So the whole idea here is to give you real hands-on experience on how real production machine learning systems operate. We'll be using a lot of Python, Docker, Kubernetes, cloud services, and other open source tools. And you're essentially going to take these components and string together an actual end-to-end machine learning system. We're going to use automation. We're going to have, like graphs and real things. It's not just going to be kind of ad hoc, isolated components of an ML platform. It's going to be the complete thing, which is really, really exciting. And I feel like it's difficult to do without getting hands-on experience. I feel like there's a lot of stats that I probably could have grabbed about machine learning engineering job opportunities and other stuff like that. But anyone taking this course would be someone looking to build an entire production ML system, learn about just like all the individual components, get hands-on experience building an ML system, or just further their skill set in their given domain, be they a data scientist, machine learning engineer, machine learning platform engineer, or software engineer. Essentially what I'm trying to do here is just link the theory behind systems design and ML systems design specifically, with the actual hands-on application and experience of what real end-to-end machine learning systems look like and what they look like at scale, and how all of the different components interact with one another. By the way, if anyone has like questions at any point, feel free to just pop one in the chat. I'll occasionally kind of go back and check the Q&A just to see. Yes, unmute, awesome, and New Bedford, sweet. So yeah, moving on. So what makes this course different from other courses and other materials that's out there? So I have like a link to a Google MLOps thing here. That's kind of where I pull some diagrams from. I think this course kind of builds on top of things that you might be familiar with. So Andrew Ung has a kind of machine learning engineering for production course. It's really, really good at introducing the concepts, but I don't think there's much in terms of actual hands-on experience. Andrew Ung, as we all know, has a very soothing voice, very good educator, but I think this course intends to go significantly further than that with hands-on stuff. In addition, I think this is one of the best books to come out in essentially recent memory is Chip Hewen's like Designing Machine Learning Systems book. It's an absolutely awesome book on kind of like that links essentially business value of machine learning systems with the actual implementation and components. But we're going to go again a little bit further than that and actually implementing some of these components for ourselves in real time, which is really exciting. So a lot of hands-on stuff basically is what I'm attempting to get across here. So actual machine learning in production is like really, really hard. I just want to like impress that upon folks. Like training your first model is easy, throwing it in a Docker container is easy, even deploying it to Kubernetes is like a fundamentally easy thing to do. But doing this at scale in an automated way and in production with all the graphs and monitoring and observability is like really, really difficult. It's not just about any one of these individual components. It's about a strong combination of everything from the systems design fundamentals to the engineering process and to even like low-level computer science knowledge that you have to implement when you're working with these systems at scale. So there's a lot that goes into it, honestly, across all of the different systems. I've learned a ton working at the scale that ETSI works at. And it's like definitely led me to designing a course like this, which I'm super excited to share. So this is my honest and egotistical view of my role as a machine learning platform engineer. Essentially, like what I have to do when I build real machine learning systems is I have to have the context of the data scientists and applied scientists training the models in order to serve their models and understand what's going on. I have to kind of know what a machine learning engineer would do in between those two things. In my mind, I guess, working with somewhat similar roles, having the machine learning context and the software engineering context. But in addition, I also have to have the platform engineering experience to build these systems at scale. I need to work with the cloud, Kubernetes, understand like a lot of networking stuff, a lot of additional skills that maybe wouldn't come easily to either of those two aforementioned disciplines. And then finally, if I'm building platform components, I need to be a software engineer as well. I need to build scalable, reliable software that follows fundamental software engineering principles, suits users' needs, and is sensibly built. And I think like this kind of machine learning infrastructure space is a very difficult but interesting cross-section of all of these different roles together. You can get experience kind of as any single one of them from working on these systems at scale, which is super fun. So basically what we're going to do in this course is we're going to go from this, which is like maybe if you followed a tutorial before, you know, deploying a machine learning model. You send a request to an API, you get a prediction back, right? That's like there's 1,000 Medium posts on that. Very, very simple and straightforward. We're going to go from that, which what I would call maybe a single recommendation model, to this. We're going to a recommendation system. So this course isn't about, you know, just like deploying a model. It's not just about like a machine learning pipeline. It's about all of the components of a system operating together and how they can operate together in an actual setting. There's not going to be one way to do any single one of these. We are going to explore like different avenues when we look at each of these components and string them together. But this is essentially what we're going to be building in this course, is something like this. We're going to have a metadata store, a registry. We're going to be serving models. We're going to be monitoring them. We're going to have training pipelines. We're going to be doing a lot of different things in a lot of different fun ways, which is cool. Oh, sorry, leaning on my keyboard. I'll pause there real quick just to see if there's any questions in the Q&A. If anyone has any, feel free to ask now. I might get to them further on in the presentation too, but cool. I'll keep going for now. So the curriculum itself, it's posted in the link that Vivian shared in the chat, but we're kind of going to be going through the different components and different stages of an actual machine learning system. We're going to start with some fundamentals, both in machine learning systems and just machine learning engineering in general, in terms of both engineering and ML systems design. But then we're going to go on to individual components of a system. So we're going to start with feature systems. We're going to build some ML model training pipelines. From there, we're going to move on to actually managing machine learning experiments, moving on to actually deploying machine learning models in production. And then we're going to set up the components at the highest level, which would be ML observability and software observability, some online experimentation and reliability engineering. How do we do A/B tests? How do we actually deploy things safely? All the way towards continuous learning, which is kind of what I would say considered one of the most mature areas of machine learning infrastructure right now that a lot of companies are trying to work towards. Finally, with a small unit at the end on machine learning governance, which is the absolute highest level, but we'll also have a lot of focus on your individual machine learning projects around that time. So there's a ton here, right? Like each of the components of this curriculum could be a domain unto themselves. And the purpose here is to give you the building blocks to construct your own actual ML system. We're not going to be doing theoretical deep dives in any one of these. It's going to be a lot of hands-on work. But I would essentially expect anyone leaving this course to have the minimum amount of content and skills they need to set up the end-to-end machine learning system for a small business, medium business, their own startup, that kind of thing. If you wanted to build an e-commerce app online, I would expect that you would be able to build a recommendation system to support that application. So let's talk a little bit about the course deliverables and the process. So this is the most fun, one of the most fun components and the part that I'm most excited about, honestly. The deliverable of this course is going to be essentially a lightweight production ML system. So the assignments that are part of those course deliverables will be building on the materials and components provided in class. So think a small JIRA tickets worth of work, or essentially building and iterating on some of the fundamental components that I've given you to start with for each of those different units. For the actual project, you get to take all the building blocks and the fundamental things provided and contextualize them through a real use case. So essentially, I give you all the components and you build a real recommendation system using some real data or for a real use case, that kind of thing. The book is really open on what that project can be. I will have a rubric for that as well to focus it a little bit more. But the big thing here is that we're going to attempt to replicate real software engineering workflows. So everyone's going to have their own Git repo. We're going to submit PRs to each other for review. Hopefully communicate a lot via Slack. But the idea is that we're going to learn a lot from each other and get feedback on projects. The idea being that this course is meant to give you real experience, not just a bunch of code that you can copy and paste or lecture notes that you can refer to for interviews. It's essentially meant to replicate an actual workflow in a software engineering team. So here's kind of a GitHub example. Unfortunately, I don't think anyone here will be able to view this. It's a private repo at the moment. But this is kind of what we'll be delivering, right? Is a whole repo's worth of code and other things that we can use to build a real system. So an example of us working together in the course might be submitting a GitHub pull request. So here's just some code I've been working on. I'm just setting up some of the core infrastructure for this repository, but we might be submitting PRs to each other like this, leaving comments oh, this is cool, or, I like this or don't like this, right? And approving PRs. The whole idea being to simulate the experience of being on an actual machine learning team. So there's not much of here that's of super real value. This is just for the example itself. But the idea is that, we get to actually participate in software engineering workflows. So I'm going to merge this just because it actually contains useful stuff. And that's great. But yeah, so everyone will kind of be working together on this, and I think it'll be a lot of fun. I'll also pause there. I know I just presented a lot on the curriculum. Cool. Share the links you had in your presentation. Yes, in fact, I will share the entire presentation itself. I think people have permission to view it. Yeah, cool. I'll share this I think you folks can see the chat, correct? Even if they don't have the thing. Yeah. So cool. So that's been answered. And is a platform engineer background more advantageous to have at an earlier stage company, since you need to have a little bit about all those specialties? I would say yes, if it's what you're interested in. I think part of the big reason that you want machine learning engineers and platform engineers is to enable value with machine learning. If you're a machine learning powered application, you're essentially going to be totally limited by your ability to deliver value with machine learning. And as a company, if you don't have the software engineering and infrastructure experience necessary to set things up in a real cloud environment and in production, it doesn't matter how good the model you train is if you can't deploy it and can't monitor it and can't link it to your user data or retrain it when you need to retrain it. Essentially, like, I think having this kind of platform engineering background is super, super helpful if you're setting up new, like totally new infrastructure at a company. Now it depends on what you want to be, of course. Maybe you just want to be a machine learning engineer and interface with a platform team. It's the actual roles and responsibilities are definitely ambiguous and like poorly defined within the data science space. But yeah, I would say that like having a platform engineering background has enabled me to like actually build my own applications like for real for the first time, as opposed to simply setting up small demos or something else like that, which is cool. I hope that answered your question. Pause there for water. Cool. Yeah. Thank you. All right. From there, I'm just going to move on to the enrollment recommendations. So these are recommendations, not really requirements, but like I would recommend that although this course is intended to suit essentially anyone, whatever your level, I somewhat obviously recommend that you have at least some programming experience, 1 to 2 years, preferably Python. But if you come from like a software engineering language like Scala or Java or anything like that, totally cool as well. I'm sure you'll do more than fine. Some experience with machine learning, 1 to 2 years. This could literally be anything. If you're a boot camp graduate, you kind of fundamentally satisfy all of these requirements, honestly. And I would just ask that you've like touched a cloud environment before. So could be anything. We're using Google Cloud in this course, mostly just because it's what I work with every day at work. And therefore, if you as a student have issues, I can unblock you very quickly because I've probably seen that error before or could ask a Google engineer about it, that sort of thing. So any cloud environment totally works. I'm also familiar with AWS, and if you want to build something in AWS, you can too. But most of the examples will be Google Cloud, just because I'm super familiar with it and it'll make things go faster and hopefully unblock you better. And then in general, just some common developer tools. So hopefully you've touched Git, GitHub, just Linux, Bash scripts, that kind of thing. We'll probably be using a good amount of Docker and anything else that comes to mind, that just general development experience will kind of be helpful in moving forward in this course. And I'm going to pause one more time for questions, just because that's the kind of course at the highest level. So I want to, before moving on there, I want to give everyone time just to post and ask as many questions as you have about this course. I know a pretty quick presentation on it, but let me know if you have any specific questions about things I can answer or at the high level.
So Kyle, I think it's going to be useful if we can give people a few links for pre-work. Like all the things you touch upon, maybe they miss 1 or 2. If they have some links, they can warm up a little bit.
Oh, cool. So like pre-work, you mean like just stuff to look at and stuff like that?
For example, for Google Cloud, how much preparations you want them to do? Like, do they need to know how to upload data? How can they generate, make small apps, find public data set? Just give them some recommendation.
Absolutely. So there's actually Google Cloud has Google sponsored Coursera. Google Cloud Coursera. So Google Cloud sponsors courses on Coursera that you can also audit, just like the Andrew Ung course. And these are the ones that I took when I first, essentially when I first started at Etsy. I think I took like I took one of these like Google Cloud training sessions. I think it's on my LinkedIn actually. Yes, cool. Google Cloud Platform Fundamentals. So this is a good one here. This Google Cloud Platform Fundamentals thing. I don't want to send you the license, but getting started with application development. So this is a very useful Coursera course if you want to get familiar with Google Cloud. Also on my LinkedIn profile is this, I think it's further down actually. I think this Linux Academy, Linux Essentials is really, really useful for really high level Linux stuff. You can just connect with me and message me on LinkedIn if you have more specific like questions about anything you don't, already know about. But I'm more than happy to provide people with specific links that they can get to totally prepare. So to answer your question, Vinod, if someone hasn't gone through the bootcamp but wants some recommendations, just like hit me up on LinkedIn and I'll provide a bunch of different links. I don't have as many, like I could probably spitball a bunch, but I want to make sure that I, am suiting your specific needs as well. So happy to provide personalized help to everyone before the course as well too.
We can also post a general recommended link to our course page.
Yep, exactly. And I have some in the slides, right? Like if you wanted to read, like this Google MLOps like overview here, that's a helpful link. You can get this book or get a subscription to the O'Reilly online learning platform to read Chip Hewen's book if you were curious. And just like the Google course, you can always audit Andrew Ung's Coursera course in advance. Yeah. Cool. Other questions? Feel free to hit me with them. I'm sure people have questions about the course. All right. If not, I'll just kind of move on to a little example here. Feel free to, if you're mulling over questions or just thinking about it, feel free to throw some stuff in the chat as we go. But in the meantime, one thing that I've been working on lately is just kind of starting to set up our production infrastructure. So what I recently just merged that you saw me merge on GitHub was some fundamental core infrastructure setup for our Kubernetes cluster on Google Cloud. So I was setting up Selvin, which is a fun Kubernetes and Python-based model serving infrastructure. I was setting up Grafana, which allows us to build useful graphs for our machine learning deployments for monitoring. And I was setting up Prometheus and Alert Manager, which helps us essentially get aggregate statistics for our machine learning deployments and look at them. But I think it's more fun just to actually look at an example. So let me pop open the Google Cloud Console. So for those of you who haven't used Google Cloud before, if you sign up with a new Gmail account, you get like $300 worth of credits. That's more than you would need for this course. We'll be scaling things up and down a lot. I don't expect anything to cost a lot. I'm going to ask Google if they can give us any other benefits, which would be super nice. But essentially, we're going to be working in the cloud, but a free account should be more than enough to get what you need out of this course. We're going to be working a lot in Kubernetes, primarily because it's cloud agnostic. So while we're going to be using Kubernetes in Google Cloud, we're going to be these skills should apply to essentially any Kubernetes cluster, be it on AWS or not on AWS. So what I'm doing right now is just scaling up my cluster so that I have some nodes that I can schedule workloads on. But Yeah, there are like a lot of Google Cloud machine learning services. The goal of this course is not to make you like an expert in any specific like machine learning service. I want the skills from this course to be as widely applicable as possible. Hence Python, Docker, and stuff like that. But we're essentially going to be using Google Cloud for useful automations and infrastructure where appropriate. I can show you how to do the same thing on AWS during the course of this course if you're interested. But it'll be the fastest for me at least to do it on Google Cloud. But cool. So I've essentially set up a cluster here with a bunch of pre-deployed things. For folks who haven't seen it before, this UI is the Google Cloud Console. We're currently looking at Kubernetes engine, which is just Google Cloud Kubernetes engine, their version of Kubernetes. And what you see here under workloads are all of the things that I have deployed on Kubernetes. So I have a bunch of things that you may or may not be familiar with. They're core components you don't have to worry about right now. Some of the things will just be black box, don't worry about it. But I have one model deployed, which is this Iris model. And I have a bunch of core infrastructure components deployed to help manage it, help us reach it externally via a public URL, and to capture statistics about it. So as I scale up my cluster, we should see that workloads start to come up and things get scheduled. It might take a minute or two. Checking back for questions. Still no questions. But so what I've done here is just pre-set up a cluster that we can use to interact with Google Cloud. If I can also use the Kubernetes command line to get information about our cluster. For instance, if I want to see what's going on with my Iris model deployment, I can check that out. I can also use it to get the number of nodes in our cluster. Right now, I just created 2 nodes because that's all I really need for everything that's going on. But what'll happen is now that I've added nodes, is these pods, which is a Kubernetes concept, will slowly come up on these nodes. And what I'm looking for and what I want metrics about is Prometheus. So when that comes up, that'll help us get very, very cool statistics and graphs about our cluster. It's really close, along with Load Manager, great. So what I'm going to do as these things come up is get ready to expose the Prometheus UI. So what I just did was I forwarded, I essentially made Prometheus available in a URL. So this is Prometheus for those who haven't seen it. It essentially gets aggregate statistics from our Kubernetes cluster and allows us to easily graph them. Fortunately for us, the machine learning deployment tool that I'm using for our real-time machine learning deployment, which is this Iris model here, exports a bunch of machine learning specific metrics. So if I start typing here, I can see stuff about nodes, but I can also see stuff about like the machine learning deployment itself. And if I go back here, I've already deployed this machine learning model to Kubernetes and it's publicly available. Everyone is welcome to actually make requests to it. I will share that here. Let me first see if it's up. Oh yeah, it's on its way up. So as the pods come up, we'll be able to make requests to it, but I'll ask that you make requests to it once it is available. Let's see, anonymous attendee, Google Cloud versus AWS. Which is more popular these days? Does it differ by industry maybe? I've only used AWS and some companies send a hard line on this experience. Yeah, that's a great question. I would say that I think AWS is still more widely adopted. Like since AWS was like first to the market, I would say that they're like more established than like Azure and Google Cloud and other stuff like that. I don't think it really matters though. It's interesting to hear that some companies have set a hard line on that. In my experience, for instance, like when I was interviewing at Etsy, I had no Google Cloud experience and they were like, yeah, AWS is fine. I see it usually be pretty like a pretty soft line in terms of the kind of cloud experience you have. since almost every AWS service has a Google Cloud analog that's exactly the same. And I often do that mapping in my head. I think that AWS machine learning services are better, but I think that like SageMaker, I think is better than Google's Vertex. But the things like Kubernetes, I find easier on Google Cloud, partially because Kubernetes came from Google. And so there's a lot of like researchy things coming out like in the Kubernetes space for gRPC and other stuff like that, that I think Google Cloud is going to have a definite edge in. But let me know if that answers your question. But it's a mix. By being an ML platform engineer, what are your current thoughts on deploying notebooks versus deploying images? I am a huge proponent as a software engineer of deploying images. I think the principles of immutability and especially immutable state are super, super critical. So almost all of our pipelines, at least at my place of work, deploy images or specific versioned Python packages and that sort of thing. We currently don't deploy notebooks. I know it does work for some companies, and I think that like it does enable machine learning workflows to get to production easier. But I think that speaks more to the interface that you have between like the training and prototyping side of things, where data scientists iterate frequently in a notebook, and the interface that leads to actually deploying things to a production environment. So I feel that if you don't have a good interface for that, deploying notebooks is a good way to go. But I think if you define a very user-friendly interface and build a good production product, then data scientists can iterate as much as they want in the notebook, but still kind of have the regulated idea of containerizing that and deploying it versus the kinds of messy things that can happen in a like non-source controlled notebook. I've definitely heard horror stories of deploying notebooks to production and things going like awful. So depending on the use case, I would be hesitant to deploy a notebook, especially if it had a huge impact on the company's revenue or anything else that was high risk. I would have a tough time doing that. But notebooks are awesome, and I love prototyping in notebooks. There's a lot of notebooks in this course, I'm sure. Cool. Questions have exhausted for now. I'm going to go back here. Hope that my thing is up. Cool. So if you send that request from a terminal that I just sent in the chat, you'll get some predictions back. This is just an iris model classifier, but it's publicly available on the internet. So I think if we go to, you can probably also release it. It's probably also available. I think they have an API endpoint. Where's a doc? So they also have a kind of like Swagger documentation here in the API that I'll share that you can just view in the browser. But what I've done here is essentially deployed a model to the internet with API documentation, a lot of information about the model and the inputs and all that kind of stuff. And we can send requests to it, which is great. So what I want to do now is actually get aggregate statistics about these requests. We don't want to just kind of fly blind and say, oh, like what's happening here? We can go to Google Cloud and we can look at our actual deployment and see things like, we can see like in Google Cloud, we can see the CPU utilization, which is probably just went up when it started. It'll probably stay high every time there's a request. We can see the memory utilization. So this is essentially just the amount of space our running model takes up in memory. And we can also see the disk, which is like almost nothing since there's nothing really downloaded here. But yeah, Kubernetes gives us kind of a nice high level overview. We can probably see some logs here as well. If I go to the logs, we can see that our model in production is logging predictions. I see that it's been called 3 times. I assume those 3 times are me. But our model is essentially running in production. We can view all these things about it. Now, if we want, we can use Prometheus to actually start to graph statistics that we can use to monitor our models, create alerts, and other things. So if I refresh this, hopefully we have all of these Selvin things now. So let's see, Selvin requirement class request count. So what I'm going to do is write a little Prometheus query. And I want to see the number of requests that happened over time. Cool. So you can see here, this is over time. I'm going to reduce the amount of time. But here we can see we're starting to graph the number of requests that have come to our model in the last couple of minutes. So there's 1, 2, 3. This is the total count. If I were to like essentially make this more of a time series thing, we could, divide this by some stuff and we would see the actual requests per second or something like that. But right now over time, as we send requests, they should come up in Prometheus. So if I send like a bunch more here, what we should see is once these things are exported, usually it takes a minute or two for our deployment to publish metrics and then Prometheus to scrape those metrics. But essentially in a minute or two here, once the lag catches up, we'll actually see the number of requests jump in total because, so right there. So now we can see that I just sent, however many this was, so I sent 13 more requests just now in the terminal. And we can use all of these to see really, really useful stuff about our model. So if we want to see, for instance, the seconds, let's see the second summary. I'm kind of curious to see that. So we can see the, interesting. So we can see like, these are all code 200s, which is good. That means it was a successful request. We can see stuff on the latency, like a lot of useful stuff that we can get from all of these aggregate stats. Is this the seconds count? Oh no, I want to see the seconds. Bucket, yeah. Oh, interesting. But yeah, so we can start to do is see things like the latency for our model, the number of requests, and then we can create dashboards that we can monitor along with alerts to alert us when our model gets predictions, when our model's failing, and a whole host of other things. In this course, we'll be using Prometheus to define such alerts. We're going to be using it to create graphs in Grafana. And that's just like one of many, many components that we're going to be using it for. So this is like a super like high level basic 101 on a machine learning model deployed to Kubernetes, but actually taking a look at the details of the things going on, the like statistics in the cluster, the logs, and the whole host of other things. As part of this course, we'll essentially be automating deployments to the cluster. We'll be building more observability tools on top of this and connecting all of those individual components together. And back to questions, of which I don't see any at the moment, but everyone's welcome to ask more. If anyone's intimidated by any of this, really don't be. It just like takes really just familiarity, and more than happy to help. Get anyone familiar. Cool. Vinod, typically how large do you expect your class size to be? That's a great question. I would say like probably like I might defer to Vivian on that, but probably around like 10 folks or so. I think the idea behind the class is that like I think 7 to 10 is like my expectation right now. The reasoning for that being, of course, I can only review so many PRs, and I want to make sure that I can provide as much individualized attention to folks as possible throughout the course of this course. And that way, like everyone gets to know each other. We can like work kind of in an actual, as like a software engineering team, basically, like replicating the workflows that I actually do every day. And thank you, anonymous attendee. I appreciate that. So cool, frameworks. You were showing the use of Selvin. Is this due to some reason? Why not Bento ML, Kendra, or even ZenML? Yeah, no particular reason. When I did an evaluation of Bento, Zen, Selvin, and some other frameworks for non-TensorFlow models a while ago, Selvin had the best latency performance at the time, and also had the most features built out in Kubernetes. So for model servers, like model servers alone, like I know BentalML and ZenML are pretty good. However, like if you look at the Selvin features in regards to like production stuff, you can like build multi-armed bandits, you can do A/B tests, you can, it has a lot of out-of-the-box Prometheus metrics, so you can build easy graphs and alerts. You can do like super convenient ensembles. There's a lot of Kubernetes native stuff that's really, really hard to set up for some frameworks, or like say like a custom Flask deployment of a model that Selvin has out of the box, which I think is like really, really cool, and means we can like experiment with some stuff without essentially building an entire stack from the ground up. But all of those tools, BentalML, ZenML, are really, really cool. I just found a ZenML repo today that I was like playing around with and really loved. So like the short answer is during this course, we can use any single one of them for the model deployment if we want to experiment with it. I'll demo stuff using Selvin. I'll demo our own custom API servers, like any of that. But for certain things like experimentation, we're going to use some out of the box Selvin features because we'll need it to actually get to the starting point. Is there a tool dashboard to view the output of models? So yes, there are multiple ways that people do that right now. What a lot of folks do are capture things called prediction logs. So this is actually another thing that I think Selvin has built in, is the ability to like easily log predictions to like a streaming pipeline like Kafka, or just to like some storage bucket. And then what you can do is take the output of that data and actually use a tool like Grafana, as long as it's in an appropriate data source, to like graph the outputs and dashboard them. You can also build your own custom dashboards on top of that data. Obviously, once it's saved, if we're saving the prediction logs, we can build little our Shiny apps or Dash apps or Flask apps, and build our own graphs or custom batch jobs to do statistics. But yeah, we can actually use the same tools that we use for like the software observability, like Prometheus and Grafana, to actually view the output of the models as well, which can be very, very convenient to see the statistics. So we'll dive into that deeply during the ML observability component of this course. Is it better to start working in analytics before you dive into machine learning? I think it depends on what kind of machine learning engineer you want to be. I always wanted to be like a machine learning like software engineer, basically. So I honestly would have preferred to start in software engineering. That would have been most interesting to me. But I think like if you want to be a data scientist, then yeah, like it's perfectly fine to start in analytics. That being said, at the end of the day, it doesn't really matter where you come from. It's all about just the experience that you want. If you're interested in data science analytics, then it's better to start in analytics. If you want to be a machine learning engineer, it's like probably best to start with the software fundamentals and stuff like that. But at the end of the day, it doesn't matter as long as you get the experience that you need. How much of your job is building a model versus platform-related tasks like deploying, packaging? Yeah, that's a great question. So I almost never train any models anymore. And as such, it's not going to be a focus of this course. I essentially build every single thing, most things in production that help support a model and an actual end-to-end inference request. So that includes, like touching on stuff that's feature fetching or orchestrating, like if we're getting recommendations, if we're building a search pipeline, maybe we want to like get a set of candidates from an index first, and then we want to actually send it off to a machine learning model and score it and rank it. There's a whole bunch of complex orchestration tasks and systems that are involved there. And I essentially build all of those systems. While I touch models a lot, I actually don't train them frequently anymore. It's almost all building systems to deploy and package for me, as opposed to packaging a model myself. Is the market in the US still good for MLEs? What are the most desired skills in your opinion? Yes, I would say that the market in the US is like still good for MLEs. I think like there's been a lot of tech layoffs recently as a whole, but I think that like I mean, a Facebook recruiter was just reaching out to me yesterday about all of like the new MLE roles they're hiring for like Meta and the metaverse and stuff like that. I think there's so many companies to whom like machine learning is driving direct value now, and that's absolutely critical, right? Like, for instance, like for my company Etsy, like machine learning for search, ads, and recommendations is fundamental to the actual function of the business. It like good recommendations, good ads, good searches equals real dollars that we can actually quantify through online experiments and A/B tests. And so any company to whom machine learning is essential is definitely still hiring MLEs and definitely like puts a lot of value into that role because it's generating real value for the company. Oh man, 1 second, let me turn the lights back on. But yeah, I think overall, like the tech market, is it great as a whole? No. But is the job market good for MLEs? Yes. I think companies are like finally realizing that machine learning is like really, really valuable to them. And as a result, they're investing in machine learning in ways that we haven't seen before, which is cool. Complementing. Do you think MLEs focused on deploying models are most in need, or deep learning experts? I think deploying models and infrastructure. I think that like deep learning experts like are definitely in need. Like it's hard to find good PhD candidates with the software engineers to say operate as an applied scientist at a company like Etsy or an e-commerce company. But it depends on your background experience. I think like it'd be tough to edge into the deep learning field right now without a PhD or something like that and be doing very, very interesting work. You might be able to do it, of course. You can definitely get the experience and then pivot that way. But I would say that like the kind of general machine learning engineer, the person who like knows machine learning, can like work with it every day, but build systems is more in need than, or at least is like easier to attain and more in need than like the folks they're looking for the research team who are PhD experts and stuff like that. So it depends on your background. Like I think deep learning are like people are looking for PhD people in deep learning, but the number of roles that are out there for that are fewer than the number of folks they need who are just software engineers who know machine learning, which is super, super critical. Most of my project challenges are around processing data efficiently and not just hiring an army of data engineers. Curious what skill set and experience you would look for value engineering this process. Yeah, that's a great question. I think this, and if we're speaking about kind of like machine learning here in that regard, I think there's been a large focus recently on kind of data-centric AI as a whole, right? So I think that's like, it's tough because I think like it might not have hit maybe like, you know, a recruiter's job description yet for like, you know, like people who know how to engineer data effectively to drive value. But I think it's becoming exponentially more important. And we, like my company right now, is a whole team dedicated to data quality, essentially. How do we get good golden standard data for these problems so that we can get the best models? Like the research space is only going to go so far. We're only going to be able to deploy models that are so big. We know if we have good data, not just a lot of data, the data-centric AI can take us to that next level. So we're going to talk about this in the probably in the like a little bit in the feature systems part of the course, and like when we define some of our data sources and stuff like that, like how we essentially like feature engineering is not a part of the course, but the system will touch on like processing data efficiently. But yes, I think that like in terms of skill set and experience, I would look for I mean, I don't think I'd look for anything differently than I'd look for in someone else. I mean, like the simple fact that someone mentioned data-centric AI and the importance of that in the modeling process would be valuable to me. Other than that, I would mostly look for just someone with, you know, the engineering skill set and like machine learning know-how. But I think it comes through pretty clearly when I interview machine learning engineers or software engineers, if they're going to be very like deep learning research focus versus think about actually generating value with machine learning. which is not just about the model, it's about the system. It's very much about the data and about the processes that you set up around that. I hope that was a not too roundabout of a way to answer your question. Does anyone have any other questions? Anything else I can answer for you while I'm chilling here? Everyone's welcome to just like hit me up on LinkedIn and add follow-ups and stuff like that. Let me just, I'll share this link just in case anyone doesn't have it. But anyone is welcome to hit me up on LinkedIn, connect, like either just ask questions, more questions about the course, ask stuff, any of that. Cool, one more question. What do I think about the research versus applied scientist aspect of AI? Yeah, so I'm very like, I mean, I'm probably biased in the fact that I'm like an applied person. I see folks getting hired for roles in my company, which is called applied scientist, who are like coming from PhDs and stuff like that. And they're looking to get the hands-on enterprise experience because it's like the links I'm sharing are not being delivered. Apologies. Let me type the answer here. I'll answer this. Oh, whoops. Let me actually just open a question myself or something like that. Or can I not do that? Yeah. Well, the link is linkedin.com/in/Kyle Gallatin. You are welcome to get it from here. You can just search my name on LinkedIn. All I was doing was sending this link. But in general, I've been seeing that that there's a lot of value in the applied side of things, and I see like more research folks trying to get that value. I mean, no one honestly like everyone. It's not a like well-kept secret that like being a PhD student does not pay that much, but being a software engineer does. And so it depends on what you're interested in, of course, like what you'd like to do. I love software engineering, and I would be so bad as a researcher. So that's just me. But I think that there's a lot of fun things you can do in the software engineering space, especially in the machine learning software engineering space, that aren't just as much of a grind as being in research. But that's just a personal opinion. Research is research and applied is applied. It's going to be the same thing as math or finance or anywhere else where those two things start to diverge. Cool. If there's no other questions for now, I'm going to close out. I know we're a little bit over time, but I want to thank everyone for joining. Connect with me on LinkedIn if you have more questions. And Vivian and NYC Data Science Academy folks will be sending out more useful links that I can share with folks to help you get started prior to the course. But yeah, thanks so much for joining and hope to see you soon.
Thank you so much, Kyle. And everyone, we will follow up with the links, including the live streaming link. Thank you, everyone.